Hello, and welcome to Better Than Art School. This is our second color lecture, and it's all about hue. If you remember from the first lecture, we talked about how color is a three-dimensional concept. There's three properties, three dimensions: hue, value, and intensity. And to adequately describe a color, you need to talk about all three. To really pinpoint a color, you need to be able to think in all three of these dimensions. But today, we're just going to talk about hue. So hue is the psychological correlate of a light's wavelength. And the color wheel, you could really think of it as a hue wheel. Each segment corresponds to a wavelength. So in other words, you have light vibrating at different wavelengths, and the way our eyes and brain encode that are the different colors of the color wheel. So how does that work? So take light. Light, you can think of it as these tiny little photons. And it's really either a particle or a wave, but for our purposes, we're just going to talk about the particle aspect of light, and we call those photons. It's these tiny little photons vibrating, and the distance they travel during one complete vibration is a wavelength. So in other words, that's what's happening in the universe. There's these little particles doing these little things, these little dances, and your eyes and brain see color. Okay, so the visible light spectrum is a tiny sliver of all the different kinds of electromagnetic energy we've identified. We can't, so if a wavelength is shorter than violet, it moves into ultraviolet. We can't see it anymore. If a wavelength is longer than red, it moves into infrared, and we can't see it anymore. And there's a mnemonic device for the colors based on wavelength. So the longest is red. So if you go from the longest wavelength to the shortest wavelength, it's Roy G. Biv. It's red, orange, yellow, green, blue, indigo, violet. So that is the longest to shortest wavelength. Okay, so white light, that's light coming from the sun. It's all the wavelengths at equal intensity. And when they all come together, it makes white light. And white light moves in straight lines. Okay, so unless it's reflected or refracted or absorbed, what you see is light moving in straight lines. So in this case, you take a light bulb, and you got light emanating from that light bulb and hitting this piece of paper, right? And we think of it as a green sheet of paper, but what's actually happening is it's anti-green. It's absorbing every other wavelength, and then it's bouncing off. It's reflected the middle wavelength, which is green, and that's what your eyes see. So that's what's bouncing off of the paper. So the properties of the paper itself are such that all these other hues, all these other wavelengths get absorbed in the paper, but green or middle wavelength bounces off, and that's what you see. Okay, so again, hue is the psychological correlate of a wavelength, and I hope that's clear what that means now. Okay, so the hues, we call them primary colors, secondary colors, tertiary colors. Again, technically speaking, these are hues, but it's fine, we'll just call them colors. And red, yellow, blue, those are the primaries. You can mix all other colors from those three colors. And if you take two primaries, boom, you get a secondary. You take a primary and a secondary, it's like 1, 2, 3, and you get a tertiary color. So if you take yellow and blue, you get green. If you take blue and green, you get blue-green. Okay, pretty simple. And a lot of my students, they ask me, are white and black colors, right? And the simple answer is no, they're not. They're only one-dimensional colors. It's like they're only in the value dimension of color, because there's no hue associated with white or black. There's no intensity or saturation you could associate with either of these. But as color ideas, they're definitely color ideas. They're the oldest color ideas in world literature. You have white and black mentioned way before, even before red, and way before blue, actually, even though the sky is blue. The kind of a mystery. Okay, so there's a lot of mysteries about color, and there's not a direct mapping between this hue and wavelength idea. And here's sort of an example. Okay, so stare at this white circle in the middle for about 20 seconds, and then I'm going to move to a white slide afterwards. But it's not going to look like a white slide to you. If you keep staring at this white circle in the middle of this slide, it's not going to look white when I change it. Okay, so just keep staring at that white circle. Don't blink too much, don't look around the room, just keep staring at that white circle. Okay, now here's what you're probably seeing if you're still staring in the center of the slide here. You're going to see a kind of faint red orb, and then you're going to see it's kind of bluish green around it. Okay, Here's another example, and you maybe have seen this one before. Keep staring in the center, that white circle again. Just keep staring at it. You can probably guess what's going to happen when I change it, but just keep staring at it. And when I move to the white slide afterwards, just keep staring in the center where that white circle is again. Okay, here we go. You see the American flag? Okay, how does that work? Here's what's happening here is your cones in your eyes, they're getting fatigued by staring at a color for a long time. And it's called color adaptation. So as you stare at yellow too long, it produces a blue afterimage. And if you stare at green for too long, it produces a red afterimage. And nobody knows exactly why. It's kind of a mystery here. This is my favorite one. So stare at that little black dot right in the center of this image. And you know the drill by now. When I change to the second slide, just keep staring where that black dot is. And here's what's going to happen. Okay, I'm going to change to this second version of the image. And are you ready? It looks like a color image, right? But if you keep staring, if you look away for a second, you look back at it, it's actually just a black and white picture. Okay. All right, so that's a little bit about hue, and I hope you enjoy this lecture, and I'll see you next time for value. Thanks.